All right, we are going to look at section 2.4. This is the last section before we start getting ready for your test. We're dealing with linear equations in this chapter. We've looked at graphing some piecewise functions that had linear equations in them. We looked at writing equations for lines in slope-intercept form, point slope, and standard or general form. And then yesterday we looked at that linear regression idea, trying to use some data to calculate our best line. Okay? Today our focus is going to be on parallel and perpendicular lines. So I'm going to pause the recording. I want you to talk at your tables. What do you know about parallel lines? What do you know about perpendicular? How would you explain it to someone who didn't know what those terms meant? So what do we know about parallel lines? They have the same slopes. What else? If they have the same slopes, will they ever intersect?
Nope.
Okay, they don't intersect. If I was looking at a graph and I'm looking at two lines that have the same slope, I can assume they're parallel. What about the y-intercepts? Would they be the same as well? Picture two lines graphed, two parallel lines graphed on a coordinate plane. Would they have the same y-intercept?
No.
No. So they have the same slope but different y-intercepts? If they had the same slope and the same y-intercept, it would be one line, right? What do we know about perpendicular lines? Opposite and reciprocal slopes What does that mean? Opposite means we change what? The sign. One's positive, one's negative. Reciprocal means we change the fraction, right? We flip it over. All right. Another way to say that is that your first slope times your second slope will always get you a -1. If they are opposites and reciprocals, they would always multiply to be -1. Okay? So if I had a slope of 2/3, what would be the perpendicular slope? Yep, -3/2. Okay? All right. So we're going to look at writing some equations for lines that are parallel and perpendicular to a given line. The first one says we want one that is parallel to y equals 2x plus 1, and it has to go through the point -2, 1. Most common mistake, students think they need to deal with that plus 1. Has nothing to do with what we need. We want a line that's parallel to that, which means it just has to have the same slope. Doesn't have to have the same y-intercept. So all we really have to get out of this equation is that it has a slope of 2. Okay? So we want a line that has a slope of 2, and we want it to go through the point -2, 1. Which type of equation are we going to start with? Point slope, and then eventually we want to simplify it down to slope intercept. Okay? Point slope. We've got our y minus y1 equals m times x minus x1. We know our slope is supposed to be a 2. And then we're going to dump in our ordered pair -2, 1. So our y-coordinate is a 1, y minus 1. Our x-coordinate is a -2, so we're subtracting a -2, which really means we're adding 2. Okay? That is the equation in point slope form. If we want to simplify it to slope intercept, then we have to distribute. We would get 2x plus 4, and then we could add our 1 over. And then if you compare the original equation with what we just have here, does it fit what we said about parallel lines? They have the same slopes but different y-intercepts. Okay. Our second example, this time it's asking us to write one that is perpendicular. Okay. So the very first thing I'm going to do is I'm going to look at the equation they gave me, y equals 1/3 x plus 1, and I need the perpendicular slope. So the original slope is 1/3. What would the perpendicular slope be? -3. That's the slope I'm going to use. Okay? And we are given that it has to go through this point, negative 3, 6. So we would start out y minus our y coordinate equals our slope times x minus our x coordinate. Then we're going to simplify that to slope-intercept form. Distributing our negative 3 gets us negative 3x minus 9. And then our last step, we're going to add our 6 over. Adding 6 leaves me with a negative 3 for a y-intercept. Okay? All right. How is question 3 different? The equation's given in general form, yes. So it's harder to find the slope. You can't look at the equation and see the slope right away. So what we're going to have to do is take the given equation here and put it in that slope-intercept form so we can figure out what our slope's supposed to be. All right, that means we need to solve for y. That means I'm going to subtract an x to the other side, and I'm going to add an 8 to the other side. And then I'm going to divide out the 4. Okay, so I've solved that equation, put it in y equals mx plus b format. What's the given slope? Negative 1/4, okay? We want one that is parallel to that, so we still need a slope of negative 1/4. Okay, and we want it to go through this point. I'm going to pause the recording. I want you guys to try this one. All right, let's check your work. Dumping in our point, we've got a negative 5 for a y coordinate. We're subtracting a negative 5, which really means we're adding 5. I'm fine with you just writing that as y plus 5 if you want. Our slope, we said, was negative 1/4. Then we need x minus the x coordinate. Now, notice directions say start with point-slope form and simplify to general or standard form. Okay? So we need to do some distributing, but then general form means everything's on one side, right? Standard form, we have the constant on the other side. So y plus 5 equals negative 1/4 x plus 3/4. Okay? If we were going to get this in general form, we're going to move everything to one side. So I'm going to add the 1/4 x to the left side. I already have a single y there. And now I have to subtract a 3/4. But I have a 5 and I'm subtracting 3/4. What does that leave me? 4 1/4 as a improper fraction, what would that be? 4. I'm subtracting the 3/4 to that side. So I've got a 5 and I'm subtracting 3/4 from it. That leaves me 4 1/4. As an improper fraction, it would be 17/4. Okay. One of our standard ways of writing things, when we put it in standard or general form, we like to not have fractions. All right? We want those coefficients to be integers. So my last step for this one would be to times everything by 4. That will get rid of all those denominators. Okay? So if we times this whole thing by a 4, we end up with 1x plus 4y plus 17 equals 0. And that's much cleaner than the one with all the fractions in it. All right, this one says, write an equation for a line passing through negative 2, negative 6. We want it to be perpendicular to 2x minus 3y minus 9 equals 0. So start with point-slope form and put your final answer in general or standard form. Okay, I'm going to pause the recording again. I want you guys to try this. Check in with your partners once you find your slope. Make sure you're correct before you move forward. All right, so first step, we need to take this equation 2x minus 3y minus 9 equals 0. We need to get it into slope-intercept form. So I'm going to subtract the 2x over here. I'm going to add the 9 over. And then my last step would be to divide everything by negative 3. So my given slope is 2/3, but I want to have a line that's perpendicular to that. So I need a slope that would be what? Good. All right, then we're going to dump that into our equation using this point. So y minus a negative 6 would be plus 6 equals our slope times x minus a negative 2 or x plus 2. Distributing, we get negative 3/2 x minus 3. And then moving everything to one side, I'm going to add the 3/2 x to that side. I already have a y there. And when I add the 3 over, I end up with 9. Okay? Then what do we do to clean up the fractions? Yep, multiply by a 2. So if I times all of this by a 2, my final answer would be 3x plus 2y plus 18 equals 0. All right. How are we feeling about parallel and perpendicular? We okay? All right. The last little bit we're going to look at, we've been talking about slope. Slope is a term that typically refers to lines because we define slope as a constant rate of change. And when you have a linear equation, it's the same slope for the whole line. When we have a curve, we can pick 2 points to estimate the slope. Okay? Now, the 2 points that are shown here, the line connecting those points is called the secant line. And as your points get closer and closer together, you end up with what we call a tangent line. So if this point was really close to the next one, instead of having it way over here, as I move that point closer and closer, this new line is considered a tangent line, where it would just touch the curve in one spot. All right, that's what you're trying to get to. But we can use any 2 points and come up with a rate of change. So what is the rate of change between this point and that point? Okay? And depending on the points you pick, obviously you're going to get different answers. So our average rate of change, we have f of b minus f of a over b minus a. That's the same thing we use for slope, right? The change in y over the change in x. So it could look like that, where we have just 2 different x coordinates, x1, x2, and we're looking at the change in the y value at those x's divided by the change in the x value. Okay? Let's try one. All right, so it says to find the average rate of change for f of x equals x cubed. Think about what an x cubed graph looks like. Can you picture it in your mind? It has that curve, that twist. Okay? So we have this curved graph. Looks like that. And they're asking us to find the rate of change, which is like slope, between the values for x being 0 and the value for x being a 1. In other words, I want to go from here when x is 0 to here when x is 1. Does that make sense? I want to think of using those 2 points and find the slope between those 2 points. So let's figure out our t-chart. We have 2 x values given, a 0 and a 1. What would the y coordinates be? If I put a 0 into this function, x cubed, what do I get out? A 0. What do I get out if I put a 1 in? 1. So now if I'm calculating my slope, right, my rate of change between these 2 points, I need the y coordinates subtracted on top and the x coordinates on the bottom. So if I subtract in this order, 1 minus 0. I have to subtract the x's in the same order. 1 minus 0. So between those two little dots, what is the slope? Okay, so my average rate of change between 0 and 1, between those x values, is just a 1. What if I said, what's the average rate of change between 1 and 2? Now I have a much steeper line, yes? So every time you change those points you're using, when you have a curve, right, your slope is going to change. That's why it's called an average rate of change instead of a slope, because it does keep changing. All right, so let's look at the same curve, but this time we're going to estimate our slope or rate of change between x values of -2 and 0. So again, let's think about what our values would be. If we put a -2 in for x, what are we getting for y? What's -2 if I cube it? -8. Okay. And if I put a 0 in for x, we already did that one, we got 0 for y. So let's find the average rate of change between those 2 points. We're going to subtract our y coordinates, so -8 minus 0. For denominator, we're going to have the x coordinates, -2 minus 0. What do we end up with? A rate of change of 4. So between 0 here on our graph and -2, all right, we have a positive 4 slope, all right, or rate of change. All right, our last question. We have the population here on the y-axis. On the x-axis, we have the years. It says the line graph shows the population of parrots on an island declined over the 10-year period from 2001 to 2010. Measurements were taken at the beginning of each year. What was the average rate of change from 2002 to 2006? And then we're going to do 2 other questions, from 2007 to 2010 and from 2006 to 2007. Okay, so let's look at some of our data here. We are trying to look at the rate of change between the year 2002 and 2006. All right, so what are my y coordinates for those x values? In 2002, how high am I? What's that value? What kind of increments are we using on the y-axis? Are we going by 2s? The tick marks are going by 2s? So we are up at 56. All right, in 2006, we're looking at this point. What is my y coordinate? 32. So can I use those values and figure out a rate of change? Okay, change in y, doesn't matter which order you subtract them in. Okay, if we do 32 minus 56, then what do we have to put in the denominator? What order? 2006 minus 2002. So denominator is what? 4. Numerator is what? (32 minus 56). Negative what? Okay. So dividing, we end up with -6. So in that 4-year interval, the average rate of change is that the number of parrots went down by 6 each year. Does that make sense? So this would be parrots per year. Okay. I'm going to pause the recording. I want you guys to do the next 2. Looking at 2007 to 2010 and 2006 to 2007. All right, checking our work. If we look at the ordered pairs for 2007, our y-coordinate was 36. For 2010, our y-coordinate was 14. So again, we're looking for a rate of change. 14 minus 36 over 2010 minus 2007. So denominator becomes 3. Numerator becomes what? Negative 22. And again, parrots per year, right? Obviously, we can't go down a portion of a parrot. So estimate would be about negative 7, right? 21 divided by 3 would be 7. So we're losing about 7 a year in that time frame. Okay. The other one, we are looking at 2007 down to 2006, 36 minus 32. So we end up with 4 per year. And that is a positive value, right? So in the years from 2006 to 2007, if you look at your picture, we are actually increasing in that section. Does that make sense? So a connect the dot type of a graph like this, where you're looking at specific data from year to year, between every little interval, you're going to have a slightly different slope. All right? So again, we just call that an average rate of change. All right, so assignment today. Questions 5 through 16, 25, 26, 29, just part A, and then 31, 32, and 36.